All right, here we are. We are factoring. This is the factoring and zero product property review for our retake Friday, tomorrow. So here we are. I'm going to move from this screen in a minute, but you should rewind or pause on this screen. If you don't have these things marked up that I have, I think you should do that. You could also add a list of your perfect squares and a list of your perfect cubes. Perhaps it's up on the right side of the board right now. It's not always going to be there, so you might want to write that down. So mark these things up. This right here is just to review that, the factors of 40 are 5 and 8, and you can check your factors by multiplying things back together. Are 5 and 8 truly factors of 40? Yeah, because 5 times 8 is 40. All right, let's get factoring. So I'll refer to this sheet. I'll ask that you look at it, and you can use this on your retake. You can use it on all your tests from now on. So have it out and use it. So let's do some factoring. Number 6, I'll start there. Number 6, is there a GCF? No. How many terms are there? 2. So I'm wondering if I can square root both terms or cube root both terms. 25 and 16 are on the list of perfect squares, so I can square root both of them. So the square root of 25x to the 6th, which in other words means what times itself equals 25x to the 6th. The square root of 25x to the 6th is 5x to the 3rd, because 5x to the 3rd times itself is 25x to the 6th. This will be like my A term in your factored form. And then let's go to the second term that we can square root, and the square root of that is 4. This is like my B term. What am I talking about with A's and B's? A and B represents the square root of the first and second terms that are being subtracted. So now I plug my A and B values into this template, A plus B and A minus times A minus B. A plus B times A minus B, and that will be the factored form of this binomial. So it'll be 5x to the 3rd plus 4 times 5x to the 3rd minus 4. I have just factored that binomial. Yee-haw. Number 4. Can you square root both terms? Yes, the square root of r to the 4th is r squared, and the square root of 16 is 4. So factored form is going to be r squared plus 4 times r squared minus 4. And if you FOIL that back together, you will get r to the 4th. You also get positive 4r squared and negative 4r squared, but those cancel out. You'll get r to the 4th and negative 16 for your final answer. That's how you check it. The directions say factor, and I have just factored it. Notice your answers are off to the side, so you can use that to confirm that you're right or to see what they got and how do I fix my answer to get that way. Just make sure you're thinking about why the answer is the way it is. Ask a classmate for some help if you need some help. All right, let's look at number 14. So number 14, there is no GCF. Can you square root or cube root both terms? You can cube root both. The cube root of 64x to the 3rd means what times itself 3 times is 64x to the 3rd? It's going to be 4x. Oh, I should use a color there. I shouldn't use x as multiplication symbols. That leads to confusion. 4x times 4x times 4x is 64x to the 3rd. In other words, the cube root of 64x to the 3rd is 4x. The cube root of 125y to the 3rd is going to be 5y. So now looking at our template, is it the sum or difference? Are we adding the cubes or subtracting the cubes? We are adding the cubes. So I'm going to use the sum of 2 perfect cubes down here. So once I get my cube roots, my a and my b, I'm going to add them together in the parentheses. And you can't actually combine them. It's going to be 4x plus 5y. Then the next parentheses, and this is where a lot of people wrote 4x minus 5y for the next parentheses. If we were square rooting, not cube rooting, but if we were square rooting, yes, that's the template for the difference of squares. But this is the sum of cubes. And for the difference of cubes, right here we also have a similar template. So there's more stuff that goes after this a plus b. I'm going to square the a value. I'm going to take whatever this was right here and square it. Now in this case, I need to make sure that I square, again, what is this value? It's 4x. So now I take the 4x and I square it. I square the 4 and the x. So that gives you 16x squared. Next on the template, you're going to be subtracting a times b. That's a times b right there. So that'd be subtracting 4x times 5y, which gives you 20xy. And last but not least, we add whatever b squared is. Our b value is the 5y. So I'm going to take the 5y and square it, and that gives you 25y squared. That's a bad looking y. There we are. Huh, these are all sums, huh? You know, the only difference then is here, if you have a minus sign, it changes where the plus and minus signs go. You just follow the template. Better do a minus sign one. That's a flaw. Number 9. Can I cube root or square root both of these? Now 64 you can square root, but 27 is only a cube root. And 64 is also a cube root. By the way, always look for a GCF first, but there is not one here. So the cube root of the first term is 4, the cube root of the second term is 3x. So now following that template, I take the first cube root minus the second cube root, and then I multiply that with the first cube root squared. So it's going to be 16. And then I add these two cube roots multiplied together. So that gives you 12x. And then I add the second cube root, which is 3x. But I square that cube root, so I get 9x squared. There we are. Let's move to, by the way, 27 through 34 are good ones to be able to do, but it's not going to show up on this test, and I don't think it's going to show up much for this second half of the unit. It'll show up just a little bit. So I think for the short term, we should skip that. If you're not retaking, you could practice this skill. Get you ahead a little bit. But let's look at ones that have 3 terms now. So there's the answer to number 17. When you have 3 terms, you're going to be making a diamond. Let's look at number 18. Number 18, we're looking at numbers that multiply to -5 and add to 4. Notice there's no GCF there. So the ways to do that would be 5 and -1. So v. v plus 5, v minus 1. There's the factors there. Ooh, 22 is good. You know, you could think of this as x squared plus 0x minus 9. And when you do that, you're looking for numbers that multiply to -9 and add to 0, so you get 3 and -3. So it would be x plus 3 times x minus 3. Or you could have noticed that there was 2 terms and square rooted both of them. This is the difference of 2 perfect squares, because the square root of x squared is x, and the square root of 9 is 3. And then you add them and subtract them. So there's a few ways to get that correct answer, the correct factored answer. Number 24, you might be like, or 23, you might be like Mr. B. You said that we didn't have to do that slide and divide method. However, make sure you always take out a GCF first if you can. You can factor a 5 out of here, and then you get r squared plus 2r minus 63. Whether you can or cannot GCF, you still look at what is there and you ask yourself if you can factor it further. So inside the parentheses, there's 3 terms. So we're going to make a diamond and look for ways to multiply to 63 and add to 2. and that would be 9 and negative 7. So what's in yellow up there, I can factor and write as r plus 9 times r minus 7. But don't forget to bring down your GCF, your 5 out in front. Check it out. That should be the solution off to the right side. You can have, as you're checking your answers, you can have the factors rearranged. Like if you had the r plus 7 second and the r minus 7 first, that's perfectly equivalent. Let's do a little grouping. Although, does that show up on the bottom part? There we go. 35, let's look here. So 35, we're going to group, there is no GCF. We're going to group the first two and the last two. First two. And before you group the last two, that 7 is negative. So I'm going to chop slash it. And then make sure the negative sign is in the parentheses, inside of the parentheses. So let's take the GCF of the first two terms. You can factor out a 6 and an r squared, and you're left with r minus 2. Now you have to take something out of the second one. If you say that, well, there's nothing I can factor out, you need to factor out a 1. Here, though, you can factor out a 7, but remember, you want these parentheses to be exactly the same. So I need an r minus 2 in there, and to get that, I need to not factor out a 7, but I need to factor out a negative 7, because that leaves me with a positive r and a negative 2 in there, which matches the other one. Then you just take your GCFs and you put them together and you multiply them by r minus 2, the common binomial there. And if you, so this is the answer, you put a circle around it, check it off to the side. Again, if they rearrange this, if they have r minus 2 first and 6r squared minus 7 second, it's still perfectly correct. What's in the parentheses has to be exactly the same, but the order of the parentheses doesn't matter with multiplication. And you can check that because when you multiply this back together, if you were to FOIL it, if you were to check your answer on your test, you'd see that this equals the polynomial up top. All right, how is that going for factoring? That's your 4 or 5 basic steps for factoring. Always look for a GCF and then ask yourself how many terms are there, and then use that yellow sheet to follow the process. And again, add an example or add notes to that yellow sheet. Go back to the first minute of this video and take notes on that yellow sheet. And then the next one, we'll look at getting solutions, factoring equations to get solutions.